Good morning to all. I am Dr.Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kerpuram, Bangalore. Today I am going to discuss about fourth session of Mathematical Concept for Chemistry, which belongs to first semester BSc, affiliated to Bangalore North University. In this class, I have to discuss that is a two concept. One is integration and another one is probability. Now, the main objectives of these sessions are meaning of integration, rules for finding the integration, then problems solving on the integrations, then exact and inexact differentials, then probability, then applications of probability in chemistry. These we have to study in this class one by one. Now, after completion of this class, you will gain the knowledge regarding integration, then rules for finding the integration. You comes to know about what are exact and inexact differentials with examples. Then you also known about probability. Then also how it is a probability concept are useful in study the chemistry. This you have all known after the completion of this session. Then before starting of this session, you have already know about the knowledge about integration, then basic knowledge about probability, what is mean by probability, what is mean by integration, you have already known. Now what is mean by state function also already known. Then what is mean by trial and event also you have known. Then what is mean by atomic orbital, wave function and entropy, these terms you have already known before to study this session. Now coming to that is a fourth concept, that is the integration. The integration can be defined as the inverse operation of differentiation is called that is a integration. And symbolically, if differentiation of f of x dx is equal to f dash x or first derivative of f of x, then integration of first derivative of f of x dx is equal to a original function will become, that is called as a f of x, where f of x is said to be integration of f dash x or the first integration, that is the difference first derivative of that function. Therefore we say that is a if that is a d of f of x dx is equal to f dash x, this is the first derivative, then integration of first derivative you give that is a original function, and that is called as a original function is said to be a integration of first derivative of that function. Then we are finding to now coming to that is a rules for here. Integrations are, there is two types, one is definite integration, another one is indefinite integration. Suppose a time limit or that is initial and final value is written, that is a lower limit and upper limit will be a used, then that is called as a definite integration. A value will be a definite, then that is called as a definite integration. And integration whose values is indefinite, then that is called as a indefinite integration. Therefore therefore we say that is a there are two types of the integration, one is definite integration, another one is called as a indefinite integration. Now coming to that is a rules for finding the integration. Then first rule goes to that is a integration of k into f of x dx. Therefore k is constant, and that can be written as k of integration of f of x dx. Therefore here k is a constant, that should be taken outside of the integration and take the integration of that function itself, where k is constant. Then a second rule is nothing but integration of summation or subtraction, addition and subtraction of f of x plus g of x dx, means summation or subtraction of two different functions that can be separated by using a take the integration of one function and you have take minus or plus integration of other function. Therefore, integration of f of x plus g of x dx is equal to integration sign of f of x dx plus integration of g of x dx. These are the rule. These two rules are belong to, that is a indefinite integration. Then definite integration. Third rule is nothing but integration from a to b, f of x dx, and that equal to f of b minus f of a. You have to take integration of f of x means f value, f of x, that is capital F of x, then put the upper limit, that is in place of the x you have to put that is b, therefore f of b it became, and put the value of x at, that is lower limit a, therefore f of b minus f of a. This is called as a definite integration. Then another rule is nothing but integration of a to b f of x ds is equal to, that can be change the limit, that is change the limit from up lower to upper and upper to lower, that can be written as a negative sign of from integration of b to a. Just a reverse, it is making the limit reverse, that is the integration of b to a f of x dx. And this is the another rule for integration. And fifth rule is nothing but integration of a to c f of x dx is equal to integration of a to b f of x dx plus integration of b to c f of x dx. And these are the 5 rules for finding the integration. By using the these rules we can solve the problems on integration, and these are the 10 problems kept for your syllabus. Therefore, integrate the following function. First function is f of x dx, then second function is integration of dx, then third is integration of x square dx, and fourth one is integration of 1 by x dx, fifth one is integration of 1 by x square dx, sixth one is integration of 1 by x cube dx, and seventh one is integration of x to the power of n dx, and eighth one integration of e to the power of x dx, and ninth one integration of sin x dx, and 10th one is integration of cos x dx. Now come to, that is we have to find the solution for each problem. First problem goes to, that is integration of x dx. This can be written as, now here one formula will be there, integration of x to the power of n is equal to x to the power of n plus 1 divided by n plus 1, plus c will be a, that is for indefinite integration you have to put, that is a plus c. Okay, now for that you have to integration of x to the power of 1 dx means x to the power of 1 plus 1 divided by 1 plus 1 means, therefore x to the x square divided by 2 and plus c, where c is the constant called integrating constant. Therefore, integration of x dx means x square divided by 2 plus c. Then solution for 2, integration of dx, that can be written as here 1, nothing but dx means it is a 1. 1 can be written as x to the power of 0. Am I right? X to the power of 0. Then you have same formula, x to the power of 0 plus 1 divided by 0 plus 1 means x to the power of 1 divided by 1 means x plus c is the integration of dx, where c is the integrating constant. Next, third solution for third problem, integration of x square dx. This is same formula, x square x to the power of 2 plus 1 divided by 2 plus 1 means x to the power of 3 divided by 3 plus c, where c is integrating constant. Then solution for fourth, integration of 1 by x dx is equal to, we have simply say that is a differentiation of log x means 1 by x, therefore integration of 1 by x means it is a log x, therefore simply you say that is a integration of 1 by x dx is equal to log of x plus c, where c is the constant called integrating constant. Then solution fifth, the problem for, that is solution for problem 5. Then integration of 1 divided by x square dx is equal to integration of that can be written as you take that is a numerator value x to the power of minus 2 dx, then that should be written as x to the power of minus 2 plus 1 divided by minus 2 plus 1. Therefore minus 2 plus 1 means minus 1 divided by minus 2 plus 1 means minus 1. Therefore minus will be comes here, and that x to the power of minus 1 can be written as below, that is a denominator. Therefore minus 1 by x plus c is the answer for this, where c is the again integrating constant. Then solution for sixth problem, integration of 1 by x cube dx, that is similar to we can write integration of x to the power of minus 3 dx, that can be written as x to the power of minus 3 plus 1 divided by minus 3 plus 1. Therefore x to the power of minus 2 will be became divided by divided by minus 2. Therefore we are making that is a 1 minus 1 divided by 2 into x square plus c. This is the c is the integrating constant. Now seventh problem, solution for seventh, integration of x to the power of n dx means x to the power of n plus 1 divided by n plus 1 plus c, where c is the constant called integrating constant. That is same formula we are applying for solving so many problems on the basis of this formula only. Now eighth problem, integration of e to the power of x dx means we can write e to the power of x plus c, because differentiation of e to the power of x means e to the power of x. Therefore conversely we can write differentiation integration of e to the power of x dx is equal to e to the power of x plus c, where c is the integration constant. Then solution for ninth problem, integration of sin x dx, that can be written as cos x plus c. Here that is simply, it is trigonometric, it will be a it is comes from, that is a different method, but you have to keep in mind the integration of sin x dx means cos x plus c, where c is the integrating constant. Then last one is 10th problem, that is integration of cos x dx means it should be a sin x plus c. This is the simple, you have to keep in mind and you have to solve. Okay, and these problems for integration. Now coming to that is the applications of integration. It is used in the derivation of velocity constant or rate constant of a first order reaction. Second one is it is also used in the derivation of velocity rate constant or velocity constant for a second order reaction, because while deriving the first order rate constant or velocity constant and second order rate constant or velocity constant, we will come across that is the integration function. Therefore the integration is very useful for study the chemical kinetics in derivation of rate constant for first order reaction as well as second order reaction. Other that is in integration, it is used in the different area in the chemistry, that also we can be studied. Okay, then coming to that is the exact and inexact differentials. For that now, consider a quantity z depends on the two variables p and t, so that z is a function of pressure and temperature. Change in value of z brought about in two steps by changing one variable at a time. Therefore this is, we say that is a, for know that is a, to know the concept of exact and inexact differentials, consider a z is equal to f of p into t. It is just like a partial differentiation. Z is the here in which the three variables are there. One is z is a dependent variable and p and t are that is independent variable, and therefore we are changing brought by two steps. Okay, now here how it is changing. Now first one is here, from here just like a, this is slope will be there, this is the a to c and b, c to b. This is the just like a path it is takes place. How it is takes place, the first one is temperature keep constant and pressure allowed to change. Therefore, change the pressure will be changes by keeping the temperature constant. Therefore, it will comes that is A to C. Then pressure will keep constant and temperature is allowed to change. Therefore, it reaching C to B. Therefore, this is the first step is nothing but keeping the temperature constant. The value is changing from A to C, and from C to B keeping the pressure constant and temperature will be allow vary, and from A to B the both temperature and pressure allow to change. Therefore this will be a changing is takes place here. Then we can say that is a here what happened here. This is the A to C by changing A to C by changing the pressure is kept constant, that is pressure is kept, that is pressure changing the pressure at constant temperature. Here A to C is brought by keeping temperature constant and pressure will be a changing, and from C to B by changing the temperature at constant pressure. Therefore the total change in Z, what is that is changing, the Z is equal to integration of we require that is a final value A to B we required, that is a limit A to B here go via this is the C, A to C and C to D. Therefore we can write integration of A to B dz is equal to, we can write also from this integration of A to C dz plus integration of C to B dz. If it is exact, then we will get that is a d zb minus za. This is the upper limit. These cancel. Therefore, we will get that is a to b minus a. That is a integration we will get. If it is a exact value, then it is this function is said to be a exact differential, because whose value is not depends on that is a path. We can reach to the B, we can go A to B directly, or we can go to A to C, then C to B. There is no change in value. There is no change in value. Same amount will be consumed. Therefore, this function will be said to be a, it is a exact differential. It is a state function whose value is depend on that is the initial and final value. So initial is nothing but A and final will be a B. But what it is A to B will be a distance will be same, and we are going to that is a to C and C to B will be distance will be same. Therefore we say that is a it is a path independent. It depends on the initial and final stage, and hence it is called as a exact differential. Now therefore then the function is said to be a perfect or exact differential. The value of dz is independent on path of the function called state function. Therefore we can define as shortcutly the quantities whose change in values independent on the path called that is a state function, and this function are called as a exact differential or perfect differential. And example for these change in enthalpy, internal energy, entropy, free energy. These are all are state function whose values depends on initial and final stage, but not in between. It is a path independent. Therefore, these are called as a state functions. Now coming to that is the example for that is by taking that is internal energy as we can write that is the integration of A to B delta du is equal to ub minus ua. This can be also can be written as delta u. Therefore this is called as a exact differential. Therefore where u is internal energy and it is called as a exact differential. In other cases if the total change in z given by integration of A to B dz is not equal to from A to C dz and from C to B, then it is not equal to d zb minus za. Then this function is said to be inexact differential. The value dz depends on the path of the function and it is not a state function. How it is takes place here? Suppose we are going from A to B, it is the different amount of energy will be consumed, and here from go to A to C and C to B means different amount of energy will be consumed. Therefore, this AB energy is not equal to A plus C and C plus B. These are the not equal, hence it is called as a path dependent, referring to that particular path, and values depends on the path, hence it is called as a imperfect differential, and it is not a state function. And therefore we say that the quantities whose change in values depends on the path called that is inexact differential or imperfect differential. Inexact differentials is a not a state function. An example for this, heat. Heat is nothing but it is a, we are going from one place to other place. The in between that is changing the value. Therefore, it is a, not depends on initial and final stage, but it will be a works on that is a in between also. In the process also heat will be a changing. It will be in center, it may be high, it may be low, that will be a changing. Okay, therefore work done also this is the changing, and therefore it is a path dependent. These are the path dependent. Therefore by taking that is work done, the integration of A to B dw is not equal to wb minus wa. It is not equal to wb. This is the, it is the inexact differentials. Therefore, we say that is a, there are two functions, exact and inexact in differentials, and these are the most important for examination points. They may ask in examination what are exact and inexact differentials and give an example, means you have to give the any examples. Now coming to that is a fifth, another that is a concept, fifth, that is called as a probability. Now before going to study that is a probability, that is a, what is mean by trial. Trial is nothing but the performance of an experiment is called trial. Performance of the experiment is called as a trial. For example, tossing a coin. Coin having a two sides, one is head, another one is that is a tail. But just toss just throwing up, that is a tossing of coin is called as a that is a trial. And device having a six, that is a dice having a six that is sides actually. Therefore throwing of a dice card, that is a trial. Again distribution of cards, playing cards in among the players, that is called as a trials. Therefore performance of the experiment is called as a trial. Then coming to that is the event. The possible outcomes of the trial are called, the possible outcomes of a trial are called events. Now example, the outcome of a head or tail when a coin is tossed is called, that is the event. The possible outcomes means when the coin is tossed, it may be head or it may be a tail. Therefore outcome, whether it is coming the head or tail, it is called as a event. Therefore tossing of the that is coming out, that is head or tail, is called, that is a event. Again we are picking the one card from the 52 playing cards, that is called as a event. These are the example for event, and therefore we say that is a definition of now probability. Probability is nothing but the ratio of a total number of favorable events to the total number of trials is called probability. Probability simply the ratio of total number of favorable events to the total number of trials is called probability, or the ratio of events to trial is called, that is a probability. Simply this is the, we can say that is a definition of probability. Now coming to that is the application of probability in chemistry. Probability is used in the defining the atomic orbital, wave function, entropy of the system in chemistry. By using the probability concept, how the atomic orbital define. The atomic orbital is nothing but a region or area around the nucleus where the probability or chances to find the electrons maximum, called atomic orbital. Since in atom electrons are not stationary but they are continuous random in motion, so we cannot be find exact position of moving electrons, but we can find the probability of those electrons. Okay, therefore atomic orbital simply the moving of electrons continuously around the nucleus. Therefore we can say guessing the probability of or chances of position of the electrons around the nucleus, but we cannot be say that is the exact position. Therefore we say that is a it is a only probable phenomena. Probable phenomena. Next one is wave function. Wave function is nothing but current or motion of the electrons is called wave function. Again we cannot be determine or we cannot be decide, we cannot be find the exact position of electrons in the wave function, but we can be find the probability of position of electrons in the wave. Where it is moving no electrons, we can say that is the electrons may be here or there, just we are guessing, but it may be true or it may be false. That is just depends on the probability. It chances, we are making the chances, we making the guessing, that is called as a probability, because the electrons are continuous motion, that is moving in up and down movement, it is called as a wave. Then last, that is a definition is nothing but entropy of the system. We know that the degree of randomness or disorderedness of a system of a molecules in the system is called entropy. The degree of randomness or disorderedness of a molecules in the system is called entropy. In solid state, the molecules are arranged in systematic order, so entropy is very less, or it is almost all zero. Therefore, the we are guessing all molecules are closed pack, and the probability we say that is the molecules are present. The position of the molecules we can easily find in the solid state. But in liquid state, no, the molecules are somewhat moving. They can in the particular range. It is not, but it is particular range. Therefore, degree of randomness is increases. Therefore, they are somewhat random, and so entropy is more. Therefore, we can guess only, but we cannot be say exact position of the that is liquid molecules in the liquid system. In gaseous state, the molecules are arranged in most random, and so entropy is the most. Therefore, guessing we can guess, but it just guessing, but it cannot be say that is a exact. Therefore, we say that is a it is a entropy is also a only probability, just probable position we can say. It may be true or it may be false. Therefore, entropy is a state function because its value depends on initial and final stage. Therefore, uh, therefore this is the entropy by using a probable phenomena. And this completes that is this session. And so far we have explained about that is a studied about integration definition, then rules for finding the integration, then um, that is application of integration. Then we have already learnt about exact and inexact differentials, then probability, then applications of probability in chemistry. These terms we have so far learnt in this session. Now I will ask some questions. Please answer them. First answer question goes to: integration is the following operation of differentiation. Integration is following operation of differentiation. A option is inverse, second one is direct, third one is converse, and D is nothing but none of these. Therefore, first option A option is inverse, B option is direct, C option is converse, and D option is none of these. Correct the choose option. Correct choose the correct option, and correct choose the correct option for this question. I will give 10 seconds for you people. You have to answer them. The A option is correct for this question because integration is the inverse operation of a differentiation. Therefore, A option is the correct answer for uh, this question. Therefore, inverse operation is the that is the differentiation. Integration is the inverse operation of a differentiation. This is the A is correct answer. Second one, integration of any constant number is. Integration of any constant number is option A option 0, B option constant, C option constant into variable, D option none of these. I will give 10 seconds for you people. You can choose the correct option. The correct option is C because the integration of any constant number is constant number along with a variable, multiplication of that variable. Therefore, it is this is the correct option, correct answer for this question. Third question, which of the following is not a state function? A option heat, then second one is pressure, volume, and D none of these. Which one is the these are the options and choose the correct answer for this question. I will give 10 seconds for you people. Option A is the correct answer for this question because heat is not a state function, but it is not a exact differential, but it is a inexact differential. Hence, the heat, that is A option, is the correct answer for this question. Then fourth question, the which of is the exact differential quantity? Which of these exact differential quantity? First, A option is work done, B option is heat, C option is temperature, D option is none of these. I will give 10 seconds for you people. You have to choose which one is the exact differential quantity. Now here C option is the correct answer because temperature is the exact differential. Here work done is inexact and heat is inexact, but temperature is exact differential. It is a exact differential. The answer of this question will be that is a C. Then fifth question is the performance of an experiment is called. A option probability, B option trial, C option event, D option none of these. I will give 10 seconds for you people. You have to answer correct. Option for this question is that is a B. B option is the correct. It is a trial. The performance of the experiment is called as a trial. Therefore, B option is the correct answer for this question. So I made to prepare this session, I made the references of these books or referred these books. Hence, it is complete this chapter also, and this is the fourth session. Thank you.